Hello students, today we're going to talk about chapter 2 section 6, which is absolute value equations. So we want to think about absolute value equations in much the same way we would think about our linear equations of one variable, except for there's a one big difference is that we have two possible cases that we have to consider with our absolute value equations. So let's just look at sort of a very simple one. So remember, we've got absolute value bars would be these two straight lines that we could draw. Let's say you got x minus 2 inside of there, and that's equal to 4. Okay, so we want to think about what absolute value means. So if you think about the absolute value of, say, 5. So we can say that's equal to positive 5. So the absolute value, we could define that as the distance from the number we're considering to 0. So whether we had positive 5 that we took the absolute value of, or if we had negative 5 that we took the absolute value of, both of those would be the same distance from 0. So distance is always a positive. Okay, so that's what we're thinking. Doesn't matter if we have a negative that we're taking the absolute value, or if we have a positive that we're taking the absolute value of, we will always end up with a positive. Okay, so it's not possible for us to get an answer from an absolute value that is negative. So it has to be positive. Okay, now, so let's, if we said absolute value of negative 5, that's going to be positive 5, just the same as us taking the absolute value of 5. So if we apply it to this guy, we're thinking it doesn't matter what x is, if it's negative or positive. If I subtract 2 from it, that maybe gives us a negative, maybe it gives us a positive, but it will always be positive 4. That's what we're thinking. So I can plug in some negative number maybe for that, and I can plug in some positive number for that maybe, and it would give me that. So we have to consider both the positive case and the negative case whenever we're talking about absolute value equations. Other than that, really, it's the same as us doing our, solving our, linear equations with one variable. Okay, so let's go back to our problem here. So erase that. Okay. Now we want to consider the positive case. So let's just say the positive case is that we just plug in x, some value for x. So we're just saying, okay, x minus 2 equals 4. So there we go. That's the positive case. So solving this is the same as what we've done before. We're going to add 2 to both sides. X equals 6. So that's one possibility. So if we're looking at the positive case, if I plug in 6, 6 minus 2, that's 4. Absolute value of 4 is 4. So that would work. Let's look at the negative case. So we're always going to consider two cases. So the negative case, we're putting a negative for everything that's getting plugged in there, okay? So we're thinking negative gets applied to that entire thing. Okay. So the entire expression that's inside of our absolute value bars, all of that is negative. Okay, so we could distribute that negative to both of those. That would be positive. Negative times negative is a positive 2. So we're going to subtract 2 from both sides. We got negative x equals 2. So we have to divide by negative 1 on both sides. So x equals negative 2. So let's try that one. Negative 2 minus 2 is negative 4. If you take the absolute value of negative 4, that gives you positive 4, which works. So we're always going to look to see if we have two answers, two solutions, but we have to test these. So you can't just follow the procedure and you get out your two numbers and then just say, okay, well, if we want to test it, that's fine. If not, then that's okay. That's the case with our normal equations, But it's not the case with our absolute value. So it is possible that you do everything right in the process, but these proposed solutions, they don't work. So that is possible. Sometimes that will happen. So you have to treat these as possible solutions until you actually test them. So we went through and we tested both of them. We said 6 minus 2 is 4, absolute value of 4 is 4. That would work. Negative 2 minus 2, that's going to be negative 4. Absolute value of negative 4 is positive 4. So we're saying both of these work. We've tested them. So we know these are the solutions. So we have to be careful when we're dealing with absolute value equations that we actually go and test the two solutions that we get. If you don't test them, then it's possible that we could have what we think are solutions, but one or both of them wouldn't work. So you gotta test them, okay? Alright, so let's pick another one that we could do. So let's look at page 69. So we'll start out with something pretty simple. So absolute value of x, so this is number 2 on page 69. So absolute value of x equals 4. So that was pretty straightforward. We don't really have to solve anything necessarily. You can just think about what could you take the absolute value of that would give you 4. Well, either it's going to be negative 4 or positive 4. So that's kind of straightforward. If you wanted to apply our procedure to this, you can say, let's think about the positive case, x equals 4. Think about the negative case, negative x equals 4. So x equals negative 4. So then we can test those solutions. Absolute value of 4 is 4. Absolute value of negative 4 is also 4. So they both would work. So we could do that, but it's a little bit more straightforward on this one just to think about, if I want to take the absolute value of something that's going to give me 4, then I have to have 4 in there, and either it's going to be positive or negative. So that's really what we're thinking about that. Okay, so let's do one maybe it's a little bit harder. So let's get rid of these. Okay, so let's say we look at number, we'll do number 8. Okay, so we've got absolute value of x minus 3 equals 5. Okay, so absolute value of x minus 3 equals 5. Okay. So we're thinking we have to take the positive case and the negative case. So we're always going to start out with that. Once we have the absolute value by itself on one side of the equation, we're going to take and look at the positive case, which is just basically dropping this absolute value. So positive case, x minus 3 equals 5. So we're just solving this like normal. Add 3 to both sides. That gives us 8. So that's one possibility. The other one is, if we have a negative case, we got to take and put a negative in front of everything in the absolute value. So we're going to distribute that. Negative times negative is a positive. And then we're going to have 5. So let's do the opposite of adding, which is subtract. We're going to subtract 3 from both sides. So we got negative x equals 2. We're thinking I have to change the sign here. So we don't want negative x, we want positive x. Remember, we want to get the variable by itself on one side of the equation. So we're going to take in, either you could divide by negative 1, or you could just think about, we want to change the sign. So you got to make this thing positive. So we can just keep with what we've been doing. Divide by negative 1 both sides. It gives us a negative 2. So we're thinking these are 2 possible. So let's just make sure that these work. So remember, we have to do this. We have to figure out if we can plug these back in and see if they work or not. Okay. So 8 minus 3 is 5. So we've got absolute value of 5. Absolute value of 5 is 5. So that works. So we can say, yep, -2 gets plugged in. -2 minus 3 is -5. Absolute value of -5 is 5. So we're like, yeah, that one works as well. So both of those are going to be solutions. So typically, most of the time when you try these, they will work, but occasionally they won't work. So you have to test them, okay? So we want to keep that in mind. So make sure you test, which is just good to get in the habit of testing your solutions to make sure that you did them right. So on the test, we don't want to have where we think it's right and we didn't test it and it comes back and it was wrong. So it's good to get in the habit of that. Okay, so let's look at like number 12. That's probably a good one. Okay. All right, so we're looking at number 12 here. Number 12. Okay, so number 12, we've got absolute value 4x minus 11, absolute value, so these are absolute value bars, and that equals a negative 34. Okay, so we want to think about this for a second before we hop in and start working on it. Remember we said that the absolute value of whatever we're talking about, it must be a positive, because the definition of absolute value is the distance from a number to 0. So a distance must be positive. It's a positive number. So we're thinking, well, whatever this is, whatever x is, let's say it was a -5. -5 times 4 gives us -20. -20 minus 11, so that's some negative. Okay, so we have a negative, but if you take the absolute value of it, it's going to be positive. Okay, but what is this saying? It's saying that we get a negative from doing that. Well, is that possible? Nope, that's not possible. If we had something here that caused all this to be positive, and we took the absolute value of it, then that would also be a positive. We're saying it's not possible for this thing to be a negative when you take the absolute value of something. Okay? Doesn't matter what you plug in. It should be positive when we take the absolute value of it. This one's not. So we're saying there's something weird there. It's impossible. So what value could we plug in for x? Well, we're like, there is no value that we can plug in x that's going to do that. So we would say this is no solution. Okay, so we're thinking no solution because the absolute value of anything that we plug in for x should be a positive number. And here we're saying it's a negative 34. We're like, that doesn't make sense. There is no number that will do that. So since we have no number to plug in that would work, we're saying there's no solution. So that would be what we would say here. So that's one thing you can notice is when we have the absolute value isolated by itself, there's nothing in front of it, there's no division taking place, nothing like that. So we're thinking, okay, it's by itself, the absolute value is. So if I take the absolute value of everything in here, there's no number that I could plug in for x that would make this true. So it's no solution. Okay, I can't get a negative out of that. So we'll look at some other ones that, might look like it's going to be no solution, but it's not really. But here we're thinking, this is clearly going to be no solution since we have the absolute value by itself, everything inside of here, whether it's negative or positive, if I take the absolute value of it, it should be a positive, not negative. Okay. Now, let's say you didn't notice that, and we just went, woof, on, and, just blindly started working on this. So we didn't stop to think about it. So, we should still get the answer no solution. And let's do it, okay? So, positive case, so we're going to just treat this like, it's a normal absolute value problem. So, we got 4x minus 11 equals negative 34. Add the 11 to both sides. So, we got 4x. This is going to give us a negative 23. So, we got a negative. We're basically subtracting these two things. So, we got 3 and 2. So, then over here, we've got dividing by 4. So, x equals negative 23 over 4. Okay, so that's what it looks like. So remember, these are possible solutions. We haven't tried them yet, so we're just going to leave that alone for a second. Come over here, let's do the negative case. So we got 4x minus 11, and we're putting that all in parentheses with a negative front. So that's the negative case of everything inside of here. Over here we got negative 34. Distribute this, so we got negative x plus 11. Okay, so we're going to minus 11 on both sides. So we got negative 4x, negative 45. Divide by negative 4 on both sides. X equals negative, negative. If we divide that, that's going to give us a positive. 45 divided by 4, we can just leave that as 45 over 4. Okay. So we have two possible solutions. We want to test these to make sure that they're going to work. So we're expecting them not to work. We already know that this thing should be no solution. So if I test this one, it shouldn't work. So that means it's not a solution. If I test this one, it shouldn't work. That means it's not a solution. So if the two possible solutions don't work, then we have no solution. So that's what we can still catch that this is no solution and get the right answer, whether we took a second to think about it or not. So as long as you're applying the technique and you're doing everything correctly, you should still get out the correct answer, even if we have to do a little bit more work to see that. Okay. So remember, in math, there's two ways to do things. So we could do more thinking and less writing, or more writing and less thinking. So we can still get to the answer either way. Okay, so sometimes it pays to stop for a second, think about it before you hop in and start working. But if you don't, as long as you're doing the process and you're going through the correct techniques and looking at everything and not making careless errors, you should still get there. Okay. So we're going to take and test these. We're plugging in for x. So we're saying absolute value 4, and we got negative 23 over 4 minus 11. So we want this to be negative 34. So 4 will cancel out. We got negative 23 minus 11. So that's a negative 34. Take an absolute value of that. So it should equal negative 34. But if you take the absolute value of negative 34, you get positive 34. So this is not true. This is false. Okay. So we're thinking it's not equal. So we're saying not a solution on that one. So it's not a solution. So if that's not a solution, we have to throw it away. So we're like, that's not going to work. Let's try this one. So we're going to plug it back in here just like we did the other one. So absolute value of 4 times 45 over 4 minus 11, absolute value, and it should equal negative 34. Well, 4 will cancel out both there, so 45 minus 11, so that's going to be 34. So absolute value of 34. We're saying it should be negative 34, but absolute value of 34 should be 34. It's positive. So we're like, that one's not going to work either, so that one's not a solution. So we're like, that one's out too. It's not a solution. So neither one of these things worked when we tested them. It looked like it was going to work. Those were possible solutions. That's why you have to test these. So even if we're not thinking about if this is a logical thing to begin with, we can still catch it as long as we test. Okay, so that's why we got to do that. Okay, so you want to be in the habit with absolute values that you always test the possible solutions to make sure that they actually are going to work. So that will catch us, if we don't notice this. Okay, so we're saying not a solution, not a solution. So therefore, there is no solution to this. So this was our answer. Okay, for this particular problem, we're saying there is no solution. I can't plug anything in for x that's going to make it true. So that's our solution. Okay. Our solution for this is there is no solution. Okay, that's our answer. Alright, so let's look at another one. So let's do number 20, okay? So let's erase this, and then we'll look at number 20. we got that cleaned off. Over 20. Okay, we've got -3 absolute value. We've got x minus 1, close absolute value. We've got -9. Now, looking at this one, we could think to ourselves, oh, we got a -9 sitting over here, so maybe this one's no solution. We just got done with the, one that had no solution. But remember, that one had the absolute value isolated on one side by itself. This one, we haven't done that yet. Okay, so we've got this -3 that's being multiplied by the absolute value. So if we had something that was positive, that we get from taking the absolute value of something, and then you multiply it by a negative, then yeah, you could get a negative number from that. So -9 is possible. So we haven't had any illogical statements yet. So the way that you have to evaluate this to see whether or not it's going to be no solution is you got to get the absolute value by itself first. Okay. So we have to go over here and think about what's the opposite of multiply by -3. We want to divide both sides by -3. So over here, -3. That's going to cancel out. We're getting the absolute value by itself first. Negative divided by negative is a positive. 9 divided by 3 is 3. So now we can look and see whether this makes sense or not. So don't try to figure out whether or not it's going to be no solution or it's going to work or that it's possible to work until you've got the absolute value by itself. So if we're multiplying by -3, you got to divide by -3 on both sides. If we had been dividing this by like -4, then I'd have to multiply by -4 on both sides. Okay, so once you've got the absolute value isolated, then you can look and see whether or not it's going to work or not. Okay, so that's going to be positive case and negative case now. So we're just back to solve this like normal. Okay, so we can go ahead and write out the negative case. So we got that guy. So we're going to add 1 to both sides. X equals 4. We're going to distribute, so we get a positive 1 here. Subtract 1 from both sides, so it gives us 2. Divide by -1, so that's going to give us x equals -2. So those are our two possible solutions. So we have to go back and see if they work. You go look in the original problem. Always go back to the original problem to test. We want to do that because if we've done work to it, then it's possible we made a mistake. And if you test it in something that you've made an error in, then possibly you could get like a false positive that it would work if it really didn't. So we want to go to the original problem, so something that we haven't done anything to yet. So we're going to go and look at -3 absolute value of x minus 1 equals -9. So we want to see if it works there. So we've got -3 absolute value x is 4 minus 1. Okay. So we're saying 4 minus 1 is 3, so we've got -3 absolute value of 3. So absolute value of 3 is 3, so we've got -3 times 3. And that's -9. So we're like, yeah, that works. So this one's good. That one is okay. We come over here, we're plugging in -2 for this. So we got -3 absolute value -2 minus 1. And then that's going to be -9. Let's see. -3 comes from that, so we got -3 absolute value of -3. So we're thinking absolute value of -3 is 3, so we got -3 times 3. Okay, so we've got -3 times 3 is -9, and that is equal to -9. So we're like, okay, great. That one is also going to work. So we want two solutions. So x equals 4 is a solution, x equals -2 is a solution. So generally speaking, we're going to get two solutions when we do absolute values. So we're saying if I have one where like none of those work, then yeah, we'd have no solution. But typically we're going to have two solutions. And so we check both of these, they work. Remember, you got to test these, okay? Alright, let's look at another one. Maybe a couple more. Okay, so let's look at let's do number 26. Okay. So -26. Erase this one first. Alright, so that's going to be, well, let's do 24 and then 26. So we'll do 24 first. Okay. So change that one up. 24, we've got 9x plus 6 inside the absolute value. And then we got minus 7 equals 17. So we would want to get this guy to, so once again we want to isolate this absolute value first. So we're going to add 7 to both sides. So that's going to go away. So we've got absolute value 9x plus 6. 17 plus 7 is 24. So now we see this is going to give us a positive, so that's okay. So that should work. We don't have a negative over here, so we don't have the situation where it's no solution. Okay, so we're thinking positive case. So 9x plus 6 equals 24. Negative case, we've got negative 9, or negative parentheses 9 plus 9x plus 6 parentheses. Okay, so we're thinking subtract 6 from both sides. 9x equals, so this will be like 18. Divided by 9, that's going to be 2. We've got negative 9x minus 6 equals 24. Add 6 to both sides. So negative 9x equals 30. Okay, so we're going to divide by negative 9 on both sides. So that gives us, so we can simplify this one a little bit. So we're going to have a negative, we can divide by 3 both top and bottom, so that's 10 over 3. Okay, so we want to test both of these. So if we plug in 2 over here, we got 9 times 2 plus 6 minus 7 equals 17. So 18 plus 6, and then, we're going to see if we get 17 out of this. Absolute value of 24 is 24. 24 minus 7 is 17. So we're like, yep, that one works. Okay, so if we do the other one, so we're like, yeah, this one's good, 2 works. If we do this guy over here, we've got absolute value 9, plugging in negative 10 over 3. That's parentheses there. So minus or plus 6 first. So absolute value minus 7. Okay, so 3 will go into 9 3 times. 3 times negative 10 is going to be a negative 30. So negative 30 plus 6 is negative 24. Absolute value of negative 24 is positive 24. So 24 minus 7 is 17. So we're like, yep, that one works too. So both of those worked. So we're saying 24. So that problem, it gives us 2 solutions like we expect. So that's typically what's going to happen. Okay, so we have to look at that. Okay. All right. So we'll do 26 and then 28, and we'll say that's probably good enough. Okay. So let's let's erase this and go look at 26, and then we'll do one more after that, number 28. Okay. So let's get rid of this. Okay. All right, almost there. Okay. So 26, we've got negative square root of x, not square root of 6, sorry, negative absolute value of x, what we should say there, minus 3 equals 1. So that one doesn't look too bad. So we don't have x by the absolute value of x by itself yet, so that's what we should work on. So remember, we're going to get rid of this 3 first. So we have to add 3 to both sides. So that's what you're thinking. I want to get this guy by itself. So we want to get x by itself in the end, but to begin with, we have to get the absolute value of x by itself. So we've got negative absolute value of x equals 4. So we're like, okay, if I divide by negative 1 on both sides to get this by itself, so we have absolute value of x equals negative 4. So we're thinking to ourselves, we're like, can this be possible? Is this going to be something we could have? Remember, we're saying if I take the absolute value of anything, it should be a positive. So this is not possible. We should not be able to get -4 when we take the absolute value of something. So we're thinking this is no solution. Okay. Alright, so if I were to go through and test this, positive case, so like let's say I didn't notice that. Positive case, we're going to get x equals -4. Negative case, we're going to be getting -x equals -4. So, which would mean that x equals 4. So that's our two possible ones. If I go try that, what's the absolute value of -4? Well, that's 4. What's the absolute value of 4? That's also 4. Neither one of these is -4. So we're like, yep, that one wouldn't work, that one wouldn't work, so, yep. We're like, okay, there's none of the possible solutions that we had that's going to work, so that means there is no solution. So we could see that to begin with if we took a second. Once we have isolated our absolute value, okay, so you got to get it by itself. So looking at this, that looked okay to begin with because we had a positive over here, but we're not really going to be able to tell that whether or not it's going to have, a negative over here until we've isolated the absolute value. You've got to get it by itself first. Once you've done that, then you probably can tell, so you really wouldn't have to have done this part. But if you didn't see it, then, that's going to be over here, okay? So we can catch it still. Alright, let's do one more before we call it today. Okay, so let's erase this. Alright, so... Okay, so last one, 28. Okay, so we've got 5, so 28. We got 5 absolute value, -2x, -3, close absolute value, -4 equals 11. Okay, so we're thinking we want to get the absolute value by itself first, okay? So we're not going to worry about this yet. We're going to get rid of this guy first. So we're going to add the 4 to both sides. So that's going to give us 5 absolute value, -2x, -3, close absolute value. That's gone. Gives us 15. We're going to divide by 5 on both sides to get rid of this times 5. That's gone. Divide by 5 over here. So we got absolute value, -2x, -3, close absolute value. 15 divided by 5 is 3. So now we've got the absolute value by itself, and we see we have a positive. So we're like, this one looks okay. We don't have a negative over here once we've isolated this absolute value. So therefore, okay, great. We look good. So we should get 2 solutions out of this. We still want to test to make sure, but, it should be 2 answers, okay? Positive case, we've got -2x -3 equals 3. Negative case, we've got negative, so negative out front, we've got -2x -3. And so over here we've got +3 to both sides, -2x equals 6, divided by -2 on both sides, x equals -3. So we're like, that's a possible one, so we'll check that in a minute. Over here we're going to change both these signs in here. So negative negative makes that a positive 2x. Negative negative makes that a positive 3. So we're like, let's subtract 3 on both sides. So that's going to give us 2x equals 0. Divided by 2, we're like x equals 0 divided by 2 is 0. Okay? So x equals 0. That's our other possible solution. So let's see if that works. We have to go back to the original one to plug in. We're plugging in -3 to begin with. So we got, I'm going to do it here. So we got -2, plug in -3 for x, -3, -4 equals 11. So let's see if that works. So we've got -2 times -3. So that's a positive 6 minus 3. So 6 minus 3 is 3. Absolute value of 3 is 3. 15 minus 4, 11 equals 11. So we're like, yeah, that worked out. So this one is a solution. So if you come over here, we're plugging in 5, absolute value -2, plug in 0, minus 3, minus 4. So 2 times 0 is, -2 times 0 is 0. So 0 minus 3. 0 minus 3 is -3, so we've got absolute value of -3. Absolute value of -3 is 3, so we've got 5 times 3 minus 5, minus 4 is equal to 11. 15 minus 4, 11 equals 11. So we're like, yep, that one works. So both of these would be solutions. So we see that that's what we expected. We expected this to have two solutions to it. We see that's going to be -3 and 0. Both of those worked. So we want to test, want to make sure that they're going to work. If they do work, then yep, we got two solutions. That's generally what we're going to have out of this. All right, so we'll stop there for today, and so just try to work some more on those. If you got some questions, let us know, and we'll see you back on the next video. Have a good one.